Hello, welcome to the pre-algebra week of February 2nd. And welcome to February. Before we get started, I do want you to make sure that you have your math notebook out. So please remember that I am requiring that you take notes as you go through the recorded sessions, and this is going to help you when you go to do the assignments for the week. You're going to see a lot of similar assignments, and having examples to look back on will be very helpful. And just that taking notes, the hand to the paper connection really does help you remember and understand the material better. So let's warm up with something we looked at last week, where we were taking very big numbers and very large numbers and converting them to scientific notation. So the first warm-up question, you're going to change this very large number into scientific notation, and the second one, you're going to change that very small number into scientific notation. So as you're working on the warm-up, remember what the coefficient needs to be. There's a special parameters or requirements that the coefficient needs to be between two numbers, so think that through that. And go ahead and try these warm-up problems in your math notebook, and when you're ready to check your work with mine, go ahead and click play. All right, so this first large number, what do we have here? We've got 56,760,000,000 that we're going to change into scientific notation. And the first step is placing our decimal between two numbers. And remember, when we create our coefficient, when we're writing numbers in scientific notation, remember that the coefficient, or where we place that decimal, needs to be, let's see here, greater than or equal to 1, but less than 10. So it needs to be greater than or equal to 1, but less than 10. So in order for that to happen with that 56 billion number, we need to place our decimal between the 5 and the 6. And when we place it between the 5 and the 6, now our coefficient will be 5.6, and that's greater than 1 and less than 10. And then we need to figure out how many decimal places are we moving that decimal to get to the end of from the end of the number to where we placed it. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10. So our new, that's going to be the exponent. So our coefficient's going to be 5.676 times 10 to the, did we say 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Since we moved 10 places to get to that decimal point, our exponent will be raised to the 10th power. The base will be raised to the 10th power. All right, and anytime we're creating a large number, we know that it's going to be a positive exponent. Now let's look at this small number. We need to start at the same place where we need to place our decimal between two numbers so that the coefficient will be greater than or equal to 1, but less than 10. So that means we're going to place it between the 4 and the 2. And now we need to count how many places our decimal place has moved. 1, 2, 3, 4, 5, 6 places. So our coefficient is 4.2 times 10 to the negative 6. Since this represents a very small number, the exponent needs to be negative. All right, I'm going to move on to the next slide. So if you need more time, go ahead and click pause. So today we're going to spend time in this recording reviewing, adding and subtracting, multiplying and dividing numbers written in scientific notation. That's what we're going to do in the live session, and we're going to do that because we're wrapping up Unit 7 this week. So Unit 7, you're going to use the concepts that we're reviewing in the recording today: adding, subtracting, multiplying, dividing numbers in scientific notation, and in a choice assignment. So you're going to, this week, complete a choice assignment as well as complete a test over Unit 7. So please remember, this recording is only going to be a review of the second half of Unit 7. And please make sure that before you take the Unit 7 test, that you spend some time reviewing the other properties that we learned about exponents and powers in Unit 7. All right, so just a quick review: scientific notation and the vocab words you're going to hear. The number that's between 1 and 10, and it can include 1, is called the coefficient. Then the base is when we multiply it times 10, that's our base, and the exponent is the power. Remember, the coefficient must be greater than or equal to 1 but less than 10, and the base always right here always needs to be 10. All right, so let's see if these numbers are in correct scientific notation. Look at number 1. Is that in correct scientific notation? 9.4 times 10 to the third? It is. It is in correct scientific notation. So that one's good to go. Just to review, if we were to have been asked how we would write this in standard form, what we do is we would write, I like to write the coefficient, and then the exponent tells us how many places we need to move the decimal place to the right when it's positive. When it's a positive exponent, we'll move that decimal to the right. So what I did is I started at my original decimal and I moved it 1, 2, 3 places to the right, insert some zeros, so we know in standard notation that's going to be 9,400. So just a quick review of how we do that. Number 2, we've got 0.03 times 10 to the 5th power. Is that written in correct scientific notation? So look at that coefficient. Is it between 1 and 10? It is not. It is less than 1. So we need to adjust this. Let's fix it. So where should the decimal place go? It should go after the 3, so that it's 3.0 times 10 to the, since we moved our decimal place 2 places to the right, we need to adjust the exponent. So remember, originally, the exponent, since it's positive, tells us how many places to move the decimal to the right. And we moved it 2 places to adjust. So we've already moved it 2 places out of the 5 places that it needed to be. So now we're going to adjust our exponent so that it's raised to the 3rd power. And we can see that both these numbers represent the same thing, but only one of them is written in correct scientific notation. And the reason I changed the exponent again is because I changed the exponent from 5 to 3, is because we moved the decimal. We moved it 2 places to the right to get it between the 3 and the 0. So we moved it already 2 out of the 5 places it needed to be, so that's why I adjusted it to a 3. All right, looking at the last one, we've got a coefficient of 11.5. That is not in correct scientific notation because it's greater than 10. So we need to move that decimal back. We need to move it to the left 1 place. So we're going to move it to the left this time. So now it's going to be between the 1 and the 5, the 1 and the 1, so it would be 1.15 times 10. Since we moved the decimal, we need to adjust the exponent. So we need to adjust the exponent since we moved the decimal. So here we're moving the decimal back. We're moving it to the left. So that means we need to add 1 more to our exponent, because normally the exponent tells us how many places we need to move to the right when it's positive. And because we moved it back 1 place, that means that we need to adjust now our exponent to be equal to 9. Okay, so let's move on. If you need more time with this slide, go ahead and click pause. Adding and subtracting numbers in scientific notation. So let's start when we have the same power of 10, or the same exponent of 10. When we have the same exponent, or the power of 10, then all we need to do is simply add the coefficients, and then the base and the exponents will stay the same. And that's only when we have the powers that are of 10 that are the same. So we're just going to add the coefficients, and then the base and the powers will stay the same. So here we've got 4.2 times 10 to the fourth, and I put an arrow in there because I didn't have an exponent. So really what it is just 4.2 times 10 to the fourth. Don't let that little caret confuse you, and you can use that caret as well when you're writing exponents. So both of our exponents are raised to the fourth power. So that means all we need to do is focus on our coefficients and add those. So we're just going to add 4.2 plus 2.1. And what do we get? We get 1 plus 0.2 is 0.3. And then that 2 plus the 4 is 6, so it's 6.3. And then the base and the power will stay the same. So that would be our final answer, times 10 to the fourth. Same thing when we subtract. So looking at the second question, we've got 10 to the 9th, 10 to the 9th, so our bases are the same. So we just need to focus on subtracting our coefficients. So 7.8 minus 6.1, I get subtract 8 minus 1 is 7. 7 minus 6 is 1. So we get 1.7 times, we leave our base and our power the same. So 1.7 times 10 to the 9th. I'm going to move on to the next slide. So if you want to take some more notes, go ahead and click pause. What if we have different exponents? What if we have different exponents? So if we have different exponents, we're just going to add a step. We need to make the exponents the same before we can add or subtract. And that should be add or subtract, depending on what the operation is. So let's look here. We've got 10 to the 5th and 10 to the 8th. 10 to the 5th and 10 to the 8th. Those are not like powers. They're different exponents. So we need to adjust. We need to adjust our powers so that they are the same. Oops. And I always like to change it so that change the smaller number so it has the same power as the larger one. That's how I usually do it. Is I usually change the smaller power so it is the same as the larger one. And any time you adjust a power or change a power, you then have to adjust the decimal. We have to adjust the decimal place. Just like we did in a couple slides back where we were changing and making sure that the coefficient was in correct scientific notation, and if the coefficient wasn't between 1 and 10, we had to move the decimal and then also adjust the power. So now since we're going to adjust the power, then we have to change or adjust the decimal point as well. So the smaller power is that 10.5 here. It's 10.5, and we want to change it so that it's the same as the other one, and so we want to change it to 10 to the 8th. Because our other number is 6.03 times 10 to the 8th. So we're going to change the 10 to the 5th power to the 10th to the 8th power. And now we need to adjust the decimal since it's tongue-tied today. Since we changed our power and increased it by 3 to get from 5 to 8, we increased it by 3. So that means we need to move our decimal 3 places to the left. 3 places to the left. So now it's going to be 0.00245 times 10 to the 8th. And the reason we did that was that we remember, changed our decimal, or I'm sorry, not our decimal, we changed the power from 5 to 7. So now that 7 tells us that we need to move the decimal 7 places to the right, and that's why then we adjusted it and moved it to the left to compensate for that. So now we can go ahead and add our two coefficients. So we're just going to add our coefficients together. So 6.03 plus 0.00245. And when I do that, I get 6.03245 times 10 to the 8th. That is the final answer. That's our final answer. So we always change the smaller power to match the bigger one. So again, when you are, let's think about that. So when you're adding to the power, you also have to adjust the decimal. So just make sure you're adjusting the decimal as need be. All right, so moving on. Here's another one where let's look at the problem. It says 7.2 times 10 to the 5th power minus 5.03 times 10 to the 4th power. So we've got two different powers, so we want to adjust the smaller one. So we want to adjust the 5.03 times 10 to the 4th. And we're going to adjust it so that our power is 10 to the 5th to match the other one. And because we raised our power by 1, we need to move the decimal to the left. So now we'd have 0.503. And we're subtracting here, 7.2 times 10 to the 5th. We're going to focus on our coefficients. We have 7.2. 7.2 minus 0.0503. And you can use your calculator, that's okay. And when we do that, we get 7.1497 times 10 to the 5th. So a rule of thumb is if you increase the power, so you're adding to increase the power, then you need to move the decimal to the left to adjust. So if you increase your power like we did here, we went from 4 to 5, then you need to move the decimal to the left to adjust for that. Okay, so make sure you write that down in your notes somewhere. I'm going to move on to the next slide. I want you to try one on your own in your math notebook, just to make sure that you are good with this, where we are taking 5.1 times 10 to the 8th, subtracting 3.56 times 10 to the 6th. So notice you do have different powers, so you do need to adjust those before you can subtract those two numbers. So go ahead and click pause and try this in your math notebook, and then when you're ready to check your work with mine, go ahead and click play. So the rule that we just talked about is if we increase the power, then we have to move the decimal to the left to adjust. So that we're still representing the same quantity. So I like to focus on the smaller number so that we do increase it and follow that same pattern that I just talked about. So we need to increase the power of 6 to 8 so that it matches the other number. And since I increased by 2, I'm going to move our decimal 2 places to the left. So now I'm going to have 0.0356, and we're subtracting that 5.1 times 10 to the 8th. And now go ahead and keep going. And we're going to take 5.1 minus 0.0356, and we get a coefficient of 5.0644 times 10 to the 8th. And that is our final answer because it's written with the correct coefficients, that is greater than or equal to 1 and less than 10. Okay, so again, please make sure that you have these notes down. And I always, again, I'd like to see you go from the smaller, bring the smaller coefficient up to the larger coefficient to make them match. And when you increase that power of the smaller one to make it match the larger one, you're going to move the decimal to the left to adjust. So moving on, multiplying numbers written in scientific notation. So let's rewrite the numbers in scientific notation. So here, what I've done is I've just written two numbers in standard notation, and then when we multiply these two numbers together, what the answer would be in scientific notation. So let's rewrite these two numbers that are not in the green in this first equation. Let's first start with rewriting these numbers into scientific notation. So to do that, let's see here, let's do that in green, make that match. We would have 5.4 times 10. Well, if I put the decimal here, I'd have to move it 1, 2, 3 places to the right, so it'd be 10 to the third. And then we're going to multiply that by 1.1 times 10 to the, if I put my decimal here, 1, 2, 3, 4 places. And it equals that number. So do you see a pattern that occurs to go from here to what the answer is? So look at the powers. Look at the powers. So here I've got a power of 3 and a power of 7, and then we end up with a power, a power of 3, a power of 4, and then we end up with a power of 7. So it looks like if we add 3 plus 4, we get 7. And that ties back into the power of, or the property of products that we learned in the beginning of chapter 7, where when we multiply two numbers with the same base, we add the exponents together. And that's what happens here. We add the exponents together. We also multiply the coefficients together. So let's see if that pattern is the same thing with this problem. Let's use those same patterns. So let's first rewrite those numbers in standard notation, in scientific notation. So it would be 2.0 times 10 to the, well, let's see how many places we move our decimal. 1, 2, 3, 4. So it would be times 10 to the 4th times 3.1 times 10 to move that decimal 1, 2 places to the right. So it would be times 10 to the 2. And then it's going to equal that right there. So let's see if that pattern holds true. If we multiply 2 times 3.1, we get 6.2. That works. If we add our coefficients, because we're multiplying the numbers, it would be 4 plus 2, which equals 6. So do you see what the rule would be when we multiply exponents? We are going to multiply the coefficients, and then we're going to add the exponents, or the powers. So here we don't have to worry about making the coefficients the same, which is nice. Kind of like when we add and add fractions, we have to have a common denominator, but when we multiply fractions, we don't have to worry about that. Same is true with multiplying numbers in scientific notation. The powers don't need to be the same. We just multiply the coefficients and add the powers. That's the rule. So make sure you write that rule down for what you do when you multiply numbers in scientific notation. I'm going to go to the next slide now, so if you need more time to write down anything on this slide in your notes, please press pause now. All right, so the rule, here it is again, rule for multiplication. When you multiply numbers with scientific notation, multiply the coefficients together and add the exponents. The base will remain 10. So we're just going to multiply the coefficients. Oops, that highlighter's not showing up very well. That's a very faint yellow. We're going to multiply the coefficients and add the exponents. That's our rule when we multiply numbers in scientific notation. So go ahead, let's try some here. 1.5 times 10 to the 7th times 6.25 times 10 to the 5th. Let's go ahead. Multiply our coefficients. So go ahead, you can grab a calculator. That's all right if you use a calculator. 1.45 times 6.25. And when I multiply those two numbers, I get 9.0625 times 10. And then I'm going to add my exponents. 5 plus 7. 7 plus 5 is 12. So our exponent or our power would be raised to the 12th power. Go ahead and try number 2 on your own. So go ahead and click pause so that you can try that on your own, and when you're ready to check your work with mine, go ahead and click play. So we're going to start by multiplying the coefficients together. So 2.3 times 8.2. When I multiply those together, I get 18.86. And then I add my exponents together, so -6 plus 3. So -6 plus 3, watch that negative because we will end up with a -3 there. Are we oh, I really am having a hard time tongue-tying myself today. Are we in correct scientific notation? Is our coefficient greater than or equal to 1 but less than 10? No, we need to do some adjusting here. So we need to move our decimal to the left one. So it's between that 1 and the 8, so that now it's greater than or equal to 1, but less than 10. Because we moved our coefficient to the left, and remember, we're raised to a -3 here, which tells us we need to move the decimal to the left 3 times, but we already moved it to the left 1 time. So now we only need to raise it to the -2nd power, and then it is now written in correct scientific notation. So keep in mind when you're adding, subtracting, multiplying, and dividing, if you end up with a coefficient that is not between 1 and 10, you need to do some adjusting so that it is. So I'm going to move to the next slide now, so go ahead and click pause if you need to finish writing down your notes. All right, the last thing we want to go over is to review is dividing numbers written in scientific notation. It's very similar to multiplying our rules. What we're going to do is divide the coefficients. So we're going to divide the coefficients, but now we're going to subtract the exponents, just like we did when we divided two numbers that had the same base. When we divided those, we subtracted the exponents in the beginning of the unit. So we're going to take that idea and apply it here, but now we're also going to divide the coefficients. All right, so we've got 8.2 times 10 to the -6 divided by 2.6 times 10 to the 3rd. So it says rules say we divide, so I'm going to take 8.2 divided by 2.6. I'm dividing those coefficients, and when I do that, I get 3. I'm just going to round to 2 decimal places because there's a lot there, 3.15. And then I'm going to subtract my coefficients. I'm going to subtract them. I'm going to take -6 minus 3. So watch the negatives there. We're going to take -6 minus 3. So I'm going to get -9. -9 times 10 to the -9. And that's our final answer. One more for you to try on your own. I want you to try number 2 in your math notebook, and then when you're ready to check your work with mine, go ahead and click play. So we're dividing here. So I'm going to divide 3.5 divided by 6.6. 3.5 divided by 6.6. I get 0.5. I'm just going to go 2 decimal places. 0.53 times 10. I'm going to subtract my exponents. 8 minus 4. 8 minus 4 is 4 times 10 to the 4th. Are we done? Are we in correct scientific notation? No. We need to move this decimal to the right one place so that it's between that 5 and 3, so that our coefficient is greater than or equal to 1, but less than 10. Since, remember, it's a positive exponent of 4. We've got a positive exponent of 4, which would tell us initially we needed to move that decimal 4 places to the right. But we've already moved it 1 place to the right, so I'm going to change my power so that it's only to the 3rd power. And then, now we are done. Okay. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. So we are done with the review, so that brings us to our key phrase assignment. We are doing the week of February 2nd key phrase. So what I'm writing here is when you divide numbers in scientific notation, what do you do? So explain to me how you divide numbers that are written in scientific notation, and that's your key phrase assignment for this week. Again, please make sure you took good notes so that you can do really well on the Unit 7 test this week, and let me know if you have any questions as you're working this week. Have a wonderful rest of your week.